Alright, now we're going to solve a system of equations. That's a system in two variables. System of equations by addition. You might see this referred to as elimination. It's basically the same thing. And so let's take a look. When I do these, when I solve a system using elimination or addition, I keep you need to keep the equations stacked on top of each other. Now, if you looked at my previous video about substitution, I pull the equations apart and put them on each side of the page. But you have to keep these stacked, because what you want is you want this kind of you want it basically in standard form, and you want to be able to see the like terms, like the x's stacked here and the y values stacked here, y terms. So I'm going to look at this, and I'm looking for additive inverses. Now let's just refresh your memory. Additive inverses do this. For instance, oops, there goes my timer. For instance, if I give you a -3, the additive inverse is 3. If I give you an 8, the additive inverse is -8. If I give you 7, it's -7, and so forth, right? So additive inverses mean that we add them together and it gives us 0. So that's what I'm wanting to happen here. I want to be able to add some columns away so that they become 0. And I'm allowed to do anything I want to the equation, as long as it's not breaking any math rules. So what I notice is this 2 in front of the x, and I could easily put a -2 right here in front of this x, if I could multiply the bottom equation by -2. So now I'm going to move this out of the way, because I like to work sideways here. I'm going to multiply this bottom equation by -2, and I'm showing what I'm doing. Okay, and then I'm going to go ahead and write this right over here. I get -2x minus 6y is equal to, that's positive 44 looks like. Now I'm just going to copy this one, because I didn't change anything on it. Whoops, I didn't change anything. So there's 2x plus 4y is equal to -30. Now, what I wanted to happen happened. I got additive inverses for the coefficients of my x terms. These are the coefficients, right? I add them together and they give me nothing. So there's that. I have -2y is equal to 14, and that's a positive 14. Y is equal to, then I divide by -2, divide by -2, -7. So now here's how I finish up finding. Now I know this is how I finish up finding the rest of my intersection point of these two lines. I finished by substituting back. Now I can take the y equals -7 and put it into either equation. I'm going to use the top one just because I see it there. I'm going to substitute in the -7, and I'm going to see what I get for the x. So 2x minus 28 is equal to -30. Add 28 to both sides, I get -2. I get 2x is that, and x is -1. So I get -1 for that. So this is my solution right here. The solution is the point -1, -7. And if I put this x and this y back into these two equations, they will end up being equal. In other words, the left side will end up equaling the right side. Let's take a look at it, two more. Alright, so here's another example, and I'm going to look to make additive inverses. Now, don't panic when you see a fraction. What I'm going to do is just focus on this, right? Focus on what you think could be easily converted into additive inverses. I'm going to multiply the bottom by a positive 5. I'm multiplying the bottom by positive 5. So I'm going to copy the top one over. X plus 5y is 20. I'm going to multiply the bottom. Excuse me, I'm going to, multiply the bottom by I'm going to distribute the 5, right? So that turns that into -4x, right? 5 over 1 times -4/5 is -4x. And then I'm going to end up with minus 5y, and that's going to give me a 15. So now, let's add the columns. That goes away, and look what happens. I'm just tooling along, doing my own thing, trying to solve this system, and both variables have disappeared. both variables. I wasn't trying to do that, but both variables disappeared. So what do I do? If you've looked at my previous videos, I draw a stop sign, and immediately I stop and I ask the question, is that a true or false statement? This statement right here, this math statement. 0 is 35. Is that true? Heavens no. So we say that's false. And then I can now draw my conclusion as to what these lines look like if you're a visual learner. If it's false, that means they don't intersect at all, and you can just imagine that these are like this, right? I can't draw that picture because I haven't graphed them officially, but I can say no solution. They don't intersect at all. No solution. You can also write null set. Okay, when the variables disappear, you have to stop immediately and conclude whether it's a true or false statement. Let's look at one more. Alright, so now I notice that all I'm going to have to do to this, gosh, I can just multiply. I'm looking at that, and I could just get multiply the top by negative. Oh, you know what I'm looking at? I'm noticing that's a y instead of an x. Well, golly, I did that on purpose, and I just forgot. I did this on purpose to remind you. You really do need to make sure that the equation is written with the x first and the y second. Unless you are used to putting the y first, but we need to have them stacked with like terms on top of each other. So now I have a 1x and a 1/6x. So I'm going to focus on this right here. All right, I'm going to multiply the bottom row, the bottom equation by -1. Excuse me, -6. Let's multiply the bottom by -6. All right, let's take a look at what happens here. If I copy the top one, I have x plus 6y is 24. If I adjusted the bottom, then I'm going to have distributed the -6, and that's going to give me a negative x there. That's exactly what I wanted it to do. Now this is something I didn't necessarily want to happen, but it's happened, right? When I add the columns, I see that both go away. So that's a 0, and then this goes away. That's a 0. So what I've found is the variables went away. Again, make my little stop sign and ask myself the question, is this a true or false statement? Well, 0 equals 0 is actually true. So just because the variables go away doesn't mean it's like no solution always. It might mean that it's the same line, which is what is the case here, and that is, if it's true, it's the same line. So if you were going to graph them, it would look something like that, right? That would be right on top of each other. So there'd be an infinite number of solutions. We call that infinitely many, and this is how we write it. I say that x and y, and there's several ways to write it, but I go with this, x and y such that, and then just write one of the relationships, and I'll write the top one, and then close up the set. There it is. X and y such that the relationship between x and y is that, and it means this. Infinitely many solutions. That's what that means. That's what that means. Okay? Hope this was helpful. Thanks for watching.